Alrighty, so for part A, we want to find f of 2 and f triple prime of 2. So f of 2 is just going to be my constant here, and that constant is 3, and that's all good and dandy. To find my third derivative at 2, I'm going to have f triple prime of 2 over 3 factorial. And remember, that's going to equal my my coefficient. Oops, not that one. My coefficient of negative 12, which means that f triple prime of 2 is equal to negative 12 times 3 factorial, negative 12 times 6, or negative 72. Part B says find the third degree Taylor polynomial for f prime about 2 and use it to approximate to f prime of 2.1. So if I have third degree Taylor polynomial here, that is just me taking the derivative term by term and calling it a day. The derivative of this is just going to be 0. The derivative of this is going to be negative 2. The derivative of this thing here is going to be tan x minus 2. Then we're going to get negative 36 x minus 2 squared. Then we're going to get 12 x minus 2 to the third power. And that's my third degree Taylor polynomial. At this point, because we want to approximate to f prime of 2.1, that's just me plugging in and substituting in 2.1. And that is going to give me this lovely thing right here. Again, no need to simplify. Leave it like this and call it a day. We'll be happy. All right, part C. Write the fourth degree Taylor polynomial for g of x is equal to the integral of 2 to x f of t dt about x is equal to 2. Okay, so if I were to take the derivative with respect to t here, I'm going to have 3t. Then I'm going to have, let's see, t minus 2 squared. Then I'm going to have 5/3 t minus 2 to the third. Then I'm going to have 3 t minus 2 to the fourth degree. This is going to be from 2 to x. If I were to use FTC, I'm going to have 3x minus x minus 2 squared plus 5/3 x minus 2 to the third minus 3 x minus 2 to the fourth. And then if I were to use FTC for my lower bound of 2, I'm going to get 6. But then everything else cancels out because if I were to substitute in 2 here, it just cancels out. Now, this should make sense in terms of our center being at 2 here, where we have x minus 2, x minus 2, x minus 2. And theoretically, if I were to move the 6 right here, and I factor out a 3, I'm going to have a 3 x minus 2 right here with this right here. Now, also theoretically, if you did not want to use FTC and go straight to the answer, you could probably do that in terms of us knowing that, hey, we have a center at x is equal to 2, so all my terms should have at least an x minus 2 in it. So whenever I'm doing my little antiderivative of 3, it's not just going to be 3x, but it's going to be 3 parentheses x minus 2 because of my center. So honestly, if you thought about that, we didn't really need to waste time in terms of doing FTC here whenever everything's going to cancel out here with my lower limit. So speaking about that, anytime you have a lower limit right here, and that lower limit is your center in this case, most likely you could just go do your little antiderivative term by term, but just make sure that whenever you take your antiderivative of the constant, you have the center included. Okay, part D. Can f of 1 be determined from the information given? Plot twist, no. The reason why is because we are only given information of for f about x is equal to 2. So we could probably guesstimate, let's say f of 2, great, you know, because that's here in f triple prime of 2, but we can't really figure out what the actual value of f of 1 is. We can approximate it, yes, but we just don't know the exact value. So here, no, because we are only given information about x is equal to 2. And call it a day. All right, hopefully we scored high on this FRQ. Work on the 3 activities that are assigned, and I will see you guys whenever I come back.